People didn't care? What do you mean people didn't care? There you go, yeah. Well, I care. I care, dog. I'm here for you, dude. There you go, sorry. Yeah, my stream audio was weird. Thanks, Noise. I don't know, Windows every once in a while wants to just, like, switch some shit up, and just, like, I'm like, ugh. Well, that's okay. I mean... Well, if you're having a temper tantrum, I don't want to... You know, it's okay for you to, like, feel angry and stuff, but, you know, we gotta take some time to, like, cool down, right? Okay. Yeah, I see you sent that. It's okay. Yeah. Do you like having your animated profile? Isn't that pretty cool how you have that? You have an animated profile on Discord, right? Oh, you can't hear the Discord. One sec. Oh, I gotta figure this out. Okay. One sec. Yeah, it's alright. Yeah, delete the racist stuff. It's cool.
Never let this film get made.
There we go. Is my audio working now? Noise? Can you hear the Discord at least now? Yeah?
I mean, it's a very long list because I can't imagine much that didn't make.
I don't know if you're in the Discord. You can probably hear.
Evolutions that occur in a natural way, but.
All right, one sec. Woody, I'm gonna mute you real quick because I can hear like the TV.
Oh, let me mute real quick.
Yeah, thanks, dude. Yeah, you're good. Yeah. You can stay up here as long as you just mute yourself when you're not talking. You got it, dude. Noise, you can hear it, dude. Good. Does that work? My soundboard. You can hear my soundboard at least too. I don't know why Windows just decides to change my audio drivers like every other day or something. I don't get it. Ugh. Oh, you know what I did do though? I did just sign up for Zoom on this PC though, because I have a meeting with the brilliant people on what's up, Dino Nuggets?
That's dope.
I have a meeting with the brilliant people on Wednesday. They want to talk about their platform and maybe how we can like use it into our stuff. Yeah, you're good, dude.
Better?
Yeah, much better, dude.
I've been on this iPad for like 15 hours, I think.
15 hours? What do you do on your
15
iPad
hours.
for 15 hours, dog? Explain to me. Curious.
I'm not. Wait, how do you? I can't share my screen for this.
Yeah, I know, because I'm sharing.
Can't share.
I'm sharing my screen. Only one person can share their screen.
Proof that I have no life, but whatever.
I was gonna show you proof that I have no life. What?
I
No.
guess so.
Woody.
There's
Woody.
nothing to do, and there's no going outside or the pool.
Why can't you go outside? Is it too hot? It is very hot, honestly. Like, have you seen the temperatures these days?
I couldn't go to the pool because Aunt Susan wasn't here.
Aunt Susan wasn't there. Oh, do you know how to swim?
My neighbor.
Do you know how to swim?
No, my neighbor has a swimming pool.
Oh, okay. Yeah, it's not too hot in LA. It's 81 degrees. Let's see what it is in London right now. I heard Europe's getting. Oh, Europe's actually quite nice.
What about El Salvador?
El Salvador?
Yep.
Have you ever been to El Salvador?
My parents are in El Salvador right now.
That's cool. Yeah, 89 degrees, kind of hot. Lots of rain. Yeah, this happens a lot during the summer. It's very tropical. They just get rain all the time. Noise says he spent 6 hours on TikTok today. Uh-oh.
TikTok? Okay, no.
Yeah. Well, I mean... So
this kid is large.
No, well, TikTok is kind of like... It is a hole, for sure. Like, you can just go down this rabbit hole of stuff. I try to take advantage of this by, like, having... If people are going to be on TikTok, let them, like, learn some, like, cool shit.
Cringe, most likely. Could you see these random dances things?
Dude, okay, yeah. Noise, you'll like this, maybe. Wait, Noise doesn't know that much physics. Oh, Noise, we gotta get you into physics, man. But this video I posted is starting to go a little viral. It's about 2D projectile motion. I can tell because I start getting a bunch of comments, and, you know, the TikTok algorithm is actually very interesting. I'll post something, right? And it'll maybe get, like, a couple thousand hits, like, within the first 24 hours, and then it'll sit. And then a week later, it'll start boosting again like crazy. And I think it's because TikTok wants me to post again. So they like just start funneling my stuff to people to be like, hey man, you know, look, like you can get some viewers. Just please post again. It's always like a week later. What do you think about that, Rampton?
I didn't know the profile I had like a few days later. I'm watching that animate. That's crazy.
Yeah.
Do you do the animations yourself?
So these animations, I don't actually. So this is cool. So I used to do, you know, where is it? So like these types of animations, I would do these myself. Well, if this wants to load, excuse me. Wait, come on, there we go. So these types of animations, I used to do by myself, you know, with whatever memes and stuff. But nowadays, I work with this education startup called Kudu, and they have a budget for these Ukrainian animators and editors. So what I do now is I basically license out my videos to them in exchange for being able to use their editors and animators. So it's so yeah, that's why the newer ones have been having a lot higher quality of like animation, because all I do is I write the script, I record my voice, and then I give them like a rough draft of what I would like to have animated, and then they go through and they do it professionally. So
like, wait, do you pay them and they make it?
no, I don't pay them at all. Yeah, no. The company I work for, or work with, I guess, pays them, and then I just manage them. So I just, you know, I'd be like, okay, here's the whatever, here's the script, here's the audio, here's what I want, and then they send me a draft. I'm like, okay, fix this. And then they send it off to whoever the final editor is, and then they do it, and then they pipe it back to me. And then I post the version without my face on their website, and then I post the version with my face on my website. So it's kind of it's a cool like exchange.
Okay.
Yeah.
Because I want to also make videos and stuff. Like, is there a way? Do you think I can also ask them to like make some stuff for me, or?
I mean, yeah, if you got like physics concepts, like again, so, and this is where I'm kind of, because I really liked making math videos, you know, and they did a lot better. Like, for instance, my math videos go like super viral and whatnot. But they want primarily intro physics videos. So I've had to kind of shift my focus away from, because math videos build a lot more hype, and because I feel like they're more applicable to everyone.
Maybe you should sponsor a Discord server.
Maybe they should sponsor the
server.
Discord server. Yeah, exactly. Yeah, I should talk to them about that.
You should
But yeah,
do
Ranted,
that.
if you have like intro physics topics, then yes. If it's anything else, then like no, because like what kind of how like this deal works is that I'm making these videos for their physics course per se. It's like their intro physics course. So it's kind of like it's kind of an interesting deal, because I don't necessarily want to make just physics videos. I like making chemistry videos. I like making math videos, and I feel like those do a lot better sometimes because there's a lot wider audience of people that are taking math and chemistry. But the deal with these animators is physics. So I'm like, okay, if I'm going to spend time making these physics videos, I might as well use them on my own channel. So do the photoelectric effect, Noise says. Yeah, it's a little advanced. Again, it's like it's basic physics. This is right. 2D motion is what this is. But it's cool. It, you know, I get some good comments. Where was this? Someone was saying one of the comments was really funny here. Was it this one? No, it wasn't this one. Sorry, it was this one. 1D projectile motion. Yeah, someone said just use the Lagrangian for this. This was just like throwing a ball up in the air and having it come down. And I was like, dude, this is like taking an acetylene torch to light a candle. Like, you do not need a Lagrangian to solve this question. And he says it's using a cannon to kill flies. I'm like, I agree. But it's cool. But yeah, Ranted, if you want like help on making your own videos in this, I can give you like my templates and everything. Do you know how to use Premiere?
No, I can try to figure it out.
Yeah, I would definitely. Yeah. Adobe costs money. I just pay it regardless, and I write it off as part of my business expense. But
Yeah, I might do that as well.
yeah, it's the standard. You can also use DaVinci Pro is the free one everyone uses, but again, I just use Premiere. I pay the Adobe gods.
How much is it? Adobe Premiere, right?
Do you still have access to an EDU email?
I'm not sure. I might.
So if you can get it for students, if you have an EDU, it's $20 a month. If you can't, yeah, it's per month. Yeah. They're on the subscription thing now. I know it's
$55 a month. That's
yes, yeah.
Bro, I stopped using Adobe, bro.
It's heinous.
Like, that shit keeps on crashing on me. Like I
Well,
use the DaVinci I use the free version, and it's
Yes.
actually like so like nice.
Yeah, DaVinci Resolve is cool. It's free. This is it by Blackmagic. This is a good one. If you guys want to get into video editing and you want to do it for free, this is open source. And a lot of professionals use this. Like, yeah, a lot of they used it on Marvel, the Marvel movies and whatnot. A lot of professional people use this one as well. It's free. It's one of these things where like if you want the extra features and whatnot, you pay for it, but you're not going to use the extra features in what you're doing. Like this is for like people doing color grading and whatnot. But yes, Adobe products are disgustingly priced. They are, but they also have some really cool shit that has been coming out, especially with their AI stuff. Have you seen the generative fill with Adobe? Actually, you know what? My friend. What's up, dude? Actually, my friend on Instagram has it. One sec, because he's been doing it. He does a lot of really funny ones. Let me see. Fremont. Where's this guy? Fremont. Where are you, dog? Yeah, this guy. Funny. No. Where was the? Oh, maybe he only posted on his stories. Oh no, it's here. These are them. They're really funny actually. Can I not view stories in? Oh, there we go. Okay, cool. Okay, AI Photoshop. Yeah. So look at this. So you can go through the photo. You can highlight things and be like, hey, like put a hat on me or something, and it'll give you a bunch of options, and then you can choose what type of hat you want. And then you'd be like, oh, like, I don't know, he's probably saying, like, put, like, a dog behind me. It's just super funny. And then this is the final result. Or this one is, like, he has a picture, he's a DJ. He has a photo of him DJing, and he's like, turn this into a stove. And then he says, okay, cut this out, turn the background into a kitchen. And he turns the background into, like, a kitchen. And he's like, all right, now put a chef's hat on me. And then this is the final result. So instead of him DJing, it's him like cooking on the stove. Yeah. It's super cool. You can do all this really cool stuff. Yeah.
Here's the thing, you can get this all for free.
Can you with what?
Pirate it.
Yeah, you can't really pirate Adobe stuff these days because it's all cloud-based. It's super, I know back in the day you could do keys and stuff, but like it's hard when it connects to the internet. Yeah, no. It's in the last couple years. This is why I was telling Ramton, like, unfortunately, like, if you want Adobe products, you have to pay per month, because everything's on the cloud now, is what it is. And yeah, it's expensive, but it's the best. Like, I use everything. I use Photoshop. I use Illustrator. I use After Effects. I use Premiere. I use all this stuff. Noise says I'm gonna have a follow Gold Life. Yeah, you want? That's my brand account. All right. Anyways.
Yeah,
Enough about all that.
What about the math question?
We're gonna do math questions. Let's do it. All right. Let's start us off. All right. Welcome everyone to Actual Education. My name is Dr. Gold. This is Office Hours, a live stream that helps you out with math homework, science homework, all types of fun stuff. It's Monday. Everyone had a great weekend. I had a great, awesome weekend. Dope.
I'm going on vacation.
You going on vacation? That's cool. You going to Florida?
I'm on vacation 2 more
Yes.
weeks and then we're out of here.
Woody's on vacation right now. Woody, your birthday's coming up. That's super cool. Birthday coming
Yes,
up.
I'm getting V-Bucks
Who
and I'm
will
like,
Yo.
win?
What's up? Shaq is back. We got Shaq in the house.
Yo,
He's
I'm
rec-
back. I thought you
I
died.
might share.
Shaq
did,
is
bro.
recovering from becoming a bionic cyborg. They put like robot
Wait,
what?
pieces in his
Wait,
body.
what? Show
They
me.
put robot pieces in his body.
They put metal rods in his
Oh,
neck.
he just turned from
Two
being a robot.
inches-
Alright.
2 inches of height. He's
Alright.
finally taller than Gold.
Dude, anybody's taller than me. I'm not really that tall. I'm like 5'7" and a half. Yeah.
I
Damn,
know.
you're
Yeah,
short.
Yeah, my dating prospects are like,
Yeah, you gotta be over 6.
you gotta be 6 foot. What's with all these women in the 6 foot stuff? You know, like,
No, like,
Oh my
Like,
god, 6 foot is
now.
actually outrageous. Like, I don't know why girls put that shit as like.
I know, dude. Well, it's because they're delusional, dude. Have you seen the female delusion calculator? Anyone seen this?
Like me, I'm
Yeah, I've seen
I'm
that.
5'11", so like
It's called I
I'm
got
like right under.
I got
6.
standards, bro. I got standardsbro.com. You know what it is. This one's hilarious.
Like the age.
Oh yeah.
Yeah, so let's say like a girl's like, all right, I don't want anyone under 30 because maybe, but not over 35. Let's say that. Actually, you know what? No, let's be generous. Let's say 21 to 35. Okay. Let's say they don't care about race, but let's say their minimum height is 6 foot and they don't want anyone overweight. Okay. And then let's say
So that's
minimum
good
income
married.
is 6 figures, because all girls say I want a 6-figure guy or something, right? All right, let's just find
Oh
out.
no, I've seen a lot of people who say like,
Dude, this is ridiculous. Look, 0.79% of the population has these requirements. 6 foot tall, not obese, earning at least 100K. And this is also any marital status. This includes like married dudes.
Do it again, but without married dudes.
So and then they give you a delusion score in like how many cats you are. So this is 4 out of 5 cats.
What is this website called? I want to try it. Real quick.
It's called
the math
I got
problem?
standardsbro.com. It's on the sense it uses data I think from the census. Yeah, the US Census Bureau. This is all publicly available data.
So we're gonna do a math problem, right?
All right, let's do. I'm gonna do it. Do reality calculate like a male reality calculator. Yeah, for the guy version.
They should do a male but well, here's the
They
thing,
do.
like
I'm on it. It's called reality calc.
okay, well, yeah. All right, we could look at that another time. I'm curious about how that is. I feel like men's standards are a lot less, you know.
Math problem.
We don't say women have to be a certain height.
Give me a math problem. Give me a math problem.
All right, here. All right, cool. All right, here. Woody, since you're
By the way, a sense of
That's
like,
your what?
100 million
sorry,
out of
what's up, Ramton?
Yeah, I'm saying out of the U.S. population, so it's 333 million,
Yes.
which puts 2.63 million people with those qualifications. Which, as
Oh,
you
I
said, it also involves like married people, people who are in their relationship and
Yeah.
everything. Yeah, it's insane. Like especially if you're making over 6 figures.
Yeah, 6 figures
Like,
too, right?
yeah, like that already puts you at the top. I think 10% or like
Mhm.
maybe less. Like top, you're already 10%.
You're already top 10 with the 6-figure yeah,
and that's like men and women.
combined.
And so,
So like cut that in half.
yeah, so
Yeah, it's interesting. But again, if you guys want a 6-figure income, number one way, go to college. Go to college, get a nice degree in like tech or science or something, and you're pretty much guaranteed a 6-figure income. Someone will hire you for 6 figures to do something. But
Or
yes,
just have like 50. You have like 500 alt accounts in this server.
yeah, or
Easy
yeah,
as
just have 500
6-figure.
alt accounts, or I don't know, like become an NBA star. You know, which one's more likely?
The server.
Yeah, right. The server. All right, Woody, what's up, dude? Do you want to learn? You want to learn? Because I'll do. We'll go through yours real quick because I know you've been waiting and stuff, and then I'll go through all the other ones.
let the people decide what I should learn about.
Okay, you're you're going into 7th grade. Last time we learned about
No,
reducing.
I go to 8th grade next year.
8th grade. Okay. We learned about reducing fractions. Do you know anything about exponents?
No.
No. Okay. So if, for instance, if I showed you this, let's say like 2 to the 3rd. Do you know what this means?
If you put it like on top of each other, then maybe yeah.
Okay, yeah, it's on top here, right? Okay. What this means here, Woody, this is an exponent, okay? And what this means is whatever this bottom number is, you're going to multiply it by itself this number of times. Okay?
That's a Z. That's not a 2.
Okay, I'll make it nicer. It's okay. You can, you know. This is why, for instance, with my Z's, I always put a line through them because my 2's do look like Z's. Okay, here, let's... Is that a better 2?
Yeah.
Okay, cool. All right. So if I have 2 to the 3rd, that's going to mean this is 2 multiplied by itself 3 times. Okay? So that's 2 times 2 times 2. What would that be, Woody?
2 times 2.
What's 2 times 2?
14, I'm not sure.
No, you got it. What's 2 times 2?
4.
4. Okay, good. And then what is 4 times 2? You see how like I take this next one down?
4 times 2 is 8. 3 times 8 is like
No, you're
16.
done. You're done. You did 2 times 2, which was 4. Right? So like all this went away, Woody. Okay. And then this times 2, that's just 8. So that's your final answer. That's Mr. Bean. Does that make sense, Woody?
I don't get it.
You don't get it? It's okay. All right, let's try again. Okay. Let's say we have
Have what?
No, I'm just thinking. Let me think for a second. Okay. Let's say we have 3 squared, okay? What did I tell you about the bottom number and the top number here? Let me make my 2 better. You're gonna get mad at my 2s. What is
Don't remember.
Okay, so this right here, Woody, this is what's called the exponent, okay?
Exponent and then
Good.
no.
This is called the base, technically is what it is. Okay.
Base and exponent. Okay.
Good. The exponent tells you how many times the base is multiplied by itself. Okay?
So it's multiplying by 3.
So we're having 3, but it's only going to be multiplied by 3, right? Just like this is 2 times. Do you see this?
3 times 3, right?
Yeah, what's that?
3 times 3 is 9.
Good. That's why 3 squared is equal to 9. Okay?
Oh, you're trying to say 3 times 2 is 9. Or
No, it's
something.
3 to the 2 is what it is. It's not 3 times 2. 3 times 2 is equal to 6. That's something different, right?
Yeah.
We don't want to do that. Okay.
After 6.
All right, so if 3 squared, right, is equal to 3 times 3, which is equal to 9, what do you think 3 to the 3rd is equal to?
Is it 3 times 4?
No. So it's, let's remember, this is the base, Woody.
Yeah, this is the
This-
base and exponent.
Good. So this is 3 times 3 times 3. You see how there's 3 of these?
Eight, 9, 12,
Yeah, not-
15 or something.
No, close. Okay. So let's remember, let's do this
18.
like, no, close. Okay. 3 times 3. We already know what 3 times 3 is, right?
Yeah.
That was what?
9.
Good. Nice. Okay. So now I'm going to replace this, Woody. All right. So this is equal to 9 times 3. You see how I replaced this 3 times 3 with a 9?
Yeah.
Okay. And then what is 9 times 3?
93. 93. 9 times 3.
What is 9 times 3? It's not 90.
27.
27! That's good. Okay. Very good, Woody. All right. Awesome.
27. That's the answer.
Very good. Okay, cool. All right, I think this is a good introduction to exponents for you. Like, next time we'll go over, like, exponent rules. Is that cool?
Yep.
Okay, awesome. Good job, Woody. You learned about exponents today. And because you learned, Woody, you get a bond coin, which gets you closer to V-Bucks, right?
Yeah, but I'm getting more V-Bucks. But I might use the V-Bucks or maybe use it for something else.
You could use it for you can get Robux if you want. You can get a Xbox gift card.
Maybe I
or you
will.
you could get another month of Discord Nitro. I'll buy you a month of Discord Nitro if you want that. You know, whatever you want. Noise is asking.
I mean like 2, because you need like 22.
Yeah. Noise is asking, how old are people in the 8th grade? I think 14. Are you 14 in 8th grade? Is that usually right?
No, I'm like 12. I'm about to turn 13.
Is it 13 in the 8th grade? I think you must have skipped some grades then, right?
No, I didn't skip grades.
Your birthday's in... Oh, but your birthday's in July, so you're on, like, what we call, like, the cusp. Which means you're on, like, the...
I'm about to turn 13.
Let me see. How old
like-
is an 8th grader? Yeah, okay, 13 to 14. Okay, because
You don't want that in your search.
What's up? What's up, Rampton?
I don't know, like, you're gonna have that in your search history.
Oh, yeah, no, don't come after me, FBI. Oh, man. How old is an 8th grader? Just like, get him. Get him. No, I just know I was 13 in 7th grade. I remember that, 7-13. But I guess it changes. It changes whether you were born in the summer or not. Okay, cool. All right, good question, Woody. All right, let's do the next person that has a question.
We all ready?
No.
Oh, he's eating Pringles. That's cool, Woody. I like the play-by-play of your kitchen.
Like the X goes to-
Oh, actually, you know what? Can we do Noise's question? Can we do the ln of 1 minus x squared? Is this a weird one? Yeah.
It's actually pretty easy.
Is
Like,
it?
Yeah,
Because
it's-
we didn't get to this one last time, and I do want to do this one actually. Sorry. Yeah.
Okay, yeah, it's pretty easy. It's like one step.
This is one step, really?
You'll see because it's like
Look,
Okay,
look
actually-
in the chat. Someone
Alright.
baked eggs.
Nice, Woody.
Someone
Nice, Woody.
posted a picture in comment area. Take a look.
Okay, I'll take a look. Oh, nice, dude.
Thank-
Those are some dope-looking eggs. I'm a fan of these eggs. Yeah.
yeah, that's good. I like
Yeah.
the
I like the excessive use of butter. That's what I like most about eggs.
That's,
Butter's dope.
Yeah,
That's like the butter poaching.
yeah.
All right, so let me see. How do we do this one, Ramton? You want to show me what's the easy trick here? Because actually I don't see it.
So first, do we know how to do the derivative of ln x?
Is this where I do
Oh,
e to
that's
the
an
x? Do I do like e to the x and something? Is that what it is?
No, it's kind of like a trick that you do, and it's actually kind of nice. So,
If f of x is equal to like the integral of ln of x, I feel like I can say e to the f of x is equal to the integral of x. Is that what it is? And then we solve this?
no, it's gonna,
Okay, you show me. I don't know this one.
Kind of partial. So yeah, first I'll go through the ln of x. Once you know that this looks complicated,
Yeah, it looks very
but it's
complicated.
actually pretty easy.
Okay, cool.
The ln of x is the, I guess. So if you have ln of x, the integral of this, you see, I'm leaving
Yeah.
a gap in the other. Okay, so the derivative, we don't know what's the antiderivative of ln of x and everything, so it's already puts us at a tough spot.
Yeah.
But what you can do is this trick. I'm gonna say ln of x is the same thing as if 1 is multiplying to it.
Okay, I agree with that. 1
Right.
times anything is anything.
1 times anything is just itself.
Yeah.
So now what I'm gonna do is that I'm gonna do a and this is with the fact that we know that the derivative of ln of x is 1 over x.
Okay, true.
So-
Yeah, I do know that.
We already know this. Okay. Then from here you do partial or you do differentiation. What's it called? Partial
Integration by
differentiation.
parts.
Integration by parts.
Yeah.
Okay, so we do u prime for this one and the v for the other one. So
Okay.
it becomes uv
Wait,
minus.
Isn't it uv prime? Isn't it usually udv instead of v
Uh,
du?
From here.
No. Oh, so when you're selecting things here, Ramton, isn't it? I thought it's
it
usually.
doesn't matter. I mean, all you have to know is like.
Well, it does matter what you select here then eventually, right?
Yeah, because all you want to do is this is just reverse product rule, right?
Yes.
So if it's u prime, I'll do u prime v,
Okay.
right? And then it becomes equals to uv minus uv prime, right?
Oh,
Which, like,
I
if you-
see. I see. Yeah. Look at Noise. Noise is saying
Rearrange
uv
it.
minus vdu, but you're doing uv minus udv.
Yeah, I mean it doesn't matter. You can vdu,
Yeah.
Right?
Okay. Yeah. It
or
works. It
UVV.
works.
It's just,
Yeah. Yeah.
It's
Yeah.
just
Yeah.
dummy variables, anyways.
Correct.
Right? So,
Correct. Yeah.
So
I got
can,
you.
You can always do it. Yeah.
Yeah. It can
Okay,
go either way,
now-
but people are probably used to the other way. But go on.
Yeah, exactly. So now we'll do the integral of u prime or integral of u prime,
Yeah.
which is 1. The integral of 1 is x. So we
Good.
get x times v, which is our ln x,
Mm-hmm.
minus the integral of u, which is x, times the derivative of ln x, which is 1 over x, and dx.
Okay.
Oh, now look, this thing is just
X.
this right here is just 1. Yeah.
Right.
So we just get x ln x minus the integral of 1, which is x.
Good. Yeah.
Yeah, if you want
I agree with
to
that.
plus e as well. Okay. So there we go. That's the hard part about doing ln x integral. Now with this one, you only have to use the properties of ln. So you have
Oh.
writing as 1 minus x, whereas 1 minus x times 1 plus x.
Oh, this is genius. Oh, I didn't notice the difference of squares. Oh, wow.
Yeah.
Oh.
And then you just get ln of 1 minus x
Uh-huh.
plus ln of 1 plus x.
Integrate all of them.
Integrate all of this dx. Now the only thing you have to know is that now this is going to be like you can do the same thing kind of like.
But you can do
here.
u sub. You can do u sub, I guess, on it,
Yeah.
right?
So once you exactly. So you can do a u substitution for this one.
Uh-huh.
And you
But
can
it
essentially be like, oh, this is
just pulls a
a
negative
ln
one
of
out.
u. Yeah, it just pulls a negative one out. So this is would be x ln of 1 minus x.
Is there a negative here from this?
Yeah, and then I'm going to put a negative in front.
Oh, okay.
Yeah, so it becomes x, or no. We're going to have to, it's going to be like 1 minus x times ln of 1 minus x.
Oh, you're right.
Yeah.
Yeah, you're right. Yeah. Because
so
we're
it'd be
saying this
1
whole
minus
thing here is now
u, yeah,
x.
Exactly. So if or let me put it to the side. So if I have ln of u, and my u is this one,
Mm-hmm.
then my du is
Good. It's equal to negative dx. Perfect. Okay.
Yeah.
Gotcha.
So the integral of this ln of u du is u ln u minus u, and then there's a minus in front as well. Okay?
Gotcha.
So this right here is, or I can write it essentially as u minus u ln u.
Yes.
So it becomes
Plus
1
u.
minus x minus 1 minus x.
Okay. Yeah. This is a cool trick. I keep trying to tell the students about this one. You know, if you have a minus b, this is the same thing as negative b minus a. I see this come up like so many times in math, and people just don't remember it. But yeah, that's very smart. Because
you distribute the negative essentially.
exactly.
Yeah. And then with this one, same thing. If you do a u substitution, now your 1 plus x becomes the
u, but your du doesn't switch signs.
Yeah, so it becomes 1 plus x times the ln of 1 plus x minus 1
plus x. Oh,
and
okay.
if you want to, now you can combine these again. There's a plus c as well.
Yes.
So you can combine these again if you wanted to. So
does this turn into anything nice?
Yeah, I'm not sure. So 1 minus x minus 1 minus s gives us minus 2x. And the other one,
okay, because you have the minus x and the minus x. Okay, cool. So that's
Yeah.
gone. That's gone.
Yeah. The other one, we have a plus x times ln of 1 minus x. And then we also have a plus x ln of 1 plus x. And then we have a
wait.
minus.
Oh, because minus. Got you. Okay.
Yeah, minus. Yeah. And then with this one, the minus goes to the first one. So we have minus ln of 1 minus x plus ln of 1 plus x.
Good.
So once again, there's a plus c again.
Right, and the 1 and minus 1 go away.
Right here. And then the minus 2x, we leave it as it is.
Yeah.
These two, we can factor out the x and then write it in ln of 1 minus x times 1 plus x, which once again gives us 1 minus x squared. With this one...
Okay. You're factoring these two out of this.
Yeah, exactly. Yeah. And then with the other one, you'd get the subtraction rule for lns. So you would have ln of 1 plus x minus 1 minus x.
Yeah.
And then plus c. I can also check.
Yeah, I think that's right. Sensation Black says nerd. What's up, Sensation, dude? How's sunny old England doing? Yeah, I think this is right. All right, Woody, you can come back up. Come back up, Woody. There you go. Who requested to speak? Someone. Who's this? I can't see this. Oh, they just joined. What's up, Woody?
I got someone to join.
Oh, nice. Thank you, dude.
to get help us math.
Okay. Yeah, I help you with math. You're good.
So the first part, it has +2 arctan of x. Oh, arctan of... I think arctan of x is the same thing as this thing.
Which thing?
Or arc hyperbolic tan.
Oh, arctanch.
Tanch, yeah. Let me see
Ew.
if there's an
Gross.
alternative.
Arctanch.
Yeah, it's the same thing.
Oh, for
They just it would be this is apparently this is arc tangent of x.
Oh, arctanch. I see this. It's
Yeah.
ln of log of x plus 1. Okay. Oh, that's very cool, actually. I didn't know that.
Yeah, I guess 2 times arc tangent. But this is also correct. So like I don't know why they would put it in terms of arc.
Wait, the whole thing is 2 arctanch?
No, just this.
Just this part. Just this part.
Just
Yeah, I agree with
yeah.
that.
Yeah. But yeah, that's the answer. So like the hard part of this is actually like first of all, if you have to know the integral of ln, then you have to kind of see the 1 minus x squared being this thing, and then you separate the two integrals, and then it's just 2 simple u substitutions.
That's very cool.
Yeah.
Yeah, I'm surprised I didn't notice this trick. Like I should have noticed that. But then yeah, this is very cool too. I didn't know what the integral of ln of x was, but that's cool. That's just integration by parts.
Yeah, that was like there are actually like a lot of other integrals. Like so, one of the things is if people ever want to like if you have the integral of like arcs like sine inverse of x, you
Sure.
do it the same exact way. So you can actually do all of the inverse functions like this, because then you would define this as 1 times that. So this gives you x sine inverse of x minus the integral of x, and then the integral.
Oh, then the
of
derivative of sine is 1 over 1 minus x squared or something.
x squared, and then with this one again, it's a u substitution, easy, because you get like u with this one.
Yeah,
then
du. So it's just
your
ln, right?
du is negative 2x
Uh-huh.
dx, right? So like you can actually anytime you have an inverse function, you can actually, if you have the derivative of the inverse function,
Right.
you can solve it. And this is like you can generalize it essentially.
That's super cool. That's super dope.
Like you can, if you have the integral of the inverse of a function, like this is how you can write it. Like this is 1 times that, so it gives you x f inverse of x plus or minus
Good.
integral of x
F prime inverse, right?
inverse of x, prime
Prime.
dx.
Oh, very
So,
cool.
like, like you can generalize the formula always. Yeah,
Nice.
because you can always find derivatives easier than you can find integrals. And so, like, this doesn't mean that this integral is gonna be easier. But if you don't know the integral, well, obviously because this is just one thing, right? Like you either know it or you don't, right? But with this one, this gives you a better shot at like, okay, this could be something that I do, right? But this is just one thing you're dealing with, right? It's just one, like a sine inverse. All right, if I don't know it, I don't know it, right? But if you know the derivative, then it gives you like a chance to like potentially get an integral that you could solve, right? So that's the whole point of like doing something like this.
That's very cool. That's awesome. Nice question, Noise. That's a good one. Yeah, dude. Oh, I love Sensation Black and Noise like just speaking like British speak to each other in the chat. I'm just like, what are you guys saying? Like, what? It says what? How are things in the OOS? All right, Gadgy. Hey up, lad, you buzzing? Like what? Mensuration? What's mensuration? Sorry, I read that as menstruation. That's why I was asking when you were due. I'm a dude. Yes, I know. It's a joke. Also, who knows these days? I can't tell anymore. Like it's oh, that's too funny. Okay, cool. Yeah, dude. All right, cool. Oh wait, I need to give a point to the Noise for that one. That was a good one. Nice question, Noise. I learned something today. See, I always love when I learn something. You know, this is the lifelong learning I talk about. Like, learning never has to stop. Who am I adding this to? This is Noise. Actually, you know what? I did check out actually, Ramton, because I have a meeting with these people. I did download actually the Brilliant app. Have you actually ever downloaded it?
Not recently. I had it a few years ago.
It's pretty cool. It's like Duolingo, but for math and science and tech and like all sorts of stuff. You know, it's got like the streaks and like do this many lessons, and then there's a leaderboard, and I'm like, oh yeah, this is pretty dope. Yeah, it's the Duolingo, I guess, of STEM. My only question I have for the company is, yo, what's your target audience? Because it's like 160 a year. And
160 a year. Honestly, 160 a year is not bad. Like, even
I know it's like $13 a month. I get it. Yeah.
Yeah, because I think, you know, like, you also have to take into account, like, it seems like a lot, but the thing is, like, $13 a month for like an app that you're constantly using that like teaches you.
Yeah, teaching dope stuff. Yeah,
they're cheap because
they're cheap. Yeah.
Right, like if you get the cheapest tutor, it's $20 an hour,
which is like a garbage tutor.
Yeah,
dude, 20 an hour. Who tutors for 20 an hour? What?
There are some people in here that apparently are PhD tutor for like 25, 30.
Ew, stop. No, dude.
And I'm like, I don't think they actually do tutor, but like, yeah, I mean, $20 an hour is probably like a high school kid teaching.
Yeah, maybe a high school kid teaching something. Yeah,
and
for sure.
People who are running Brilliant, or at least bachelor's people, right? People who know their stuff.
Yeah.
So I know if middle school or
I think it's probably one of these things where, like, again, like the parents would maybe buy it for the kid or something, you know, which that makes sense. That's what I think their whole thing is. But they, you know, they have some cool courses. So like, I started looking at their what was it? Not the computer. Well, actually, the computer science one was pretty cool. They had courses on how video encoding works. You know how we have H.264 and like compression with JPEG and whatnot. I didn't know actually how that works, but I went through one of their lessons. And I was like, oh man, that's really cool. Now I understand it.
Like the image compression?
Yeah, how like video compression works. So apparently what it does is it looks at what pixels change and it encodes that. So instead of encoding every single pixel in like a 1080p whatever like frame, in between the frames, it looks for blocks of pixels that are the same and says, instead of like repeating that information, it just says, oh, just move these pixels a little bit. So instead of like encoding where all these pixels are, you're encoding just like a single vector of like, hey, move this block to the right or something.
Okay.
Yeah. It's again, and I didn't know it, and they had some pretty cool graphics on it, and I was like, oh, this is pretty dope. So yeah, good job, Brilliant. Like,
but yeah, like I wanted to
but they have all sorts of math courses. You know what they should do? They should list the courses here. Like, why do they not list the courses? Like, that's what you really should do. Because they had some on, like, group theory and, like, symmetry and stuff. And then I think they have some collabs with Kyrgyzstan and other ones. And I was like, oh, there is, like, kind of a wealth of, like, cool knowledge here. I just want to know how to make that accessible for kids. Because kids don't usually have a credit card that they can drop 160 on, you know?
Yeah. I think it's also like, you know, their audience is probably North America, because like $160 like to a different country, it would be like a lot more money.
Oh yeah, that'd be like a month's paycheck or something for some people.
Maybe.
Bacon.
Yeah. Yeah, like I actually like I can show something quickly after this if we have time as well, like about image because I know how image compression works, because I did take a course on like Fourier analysis, and like it was actually like a huge part of it was like about how data compression works.
Right.
Like, it was pretty cool.
Okay, cool. Yeah, we can do that. But Ethan, what's up? Let's do your question, because I think we only have 2 or 3 questions today, so maybe we'll have some time. Although, wow, we're burning time. It's already 3:48. Okay.
Hello.
What's up, Ethan?
I'm doing good.
Good. All right, nice. Okay, we're talking about golf balls. I like golf. You ever play golf, Ethan?
Never.
Never. Okay, it's okay. I didn't play golf till I got into like my later 20s. But okay, all good. All right, let's draw a ball. Okay, so I always like to draw pictures when I see physics questions. Okay, so we have. Can I please draw this ball? Thank you. Okay, cool. We have a ball here, which is being hit such that it leaves the ground at an angle of 22 degrees. Okay, so that's going to be something like this. Okay, this is going to be 22 degrees. And it leaves the floor with a velocity of 75 meters per second, okay? And now what they're asking is, what is the maximum height of the ball? Okay? That's pretty cool. All right. How do we start this question? What did we learn last time, Ethan? Like, what's the first way to... What's the first thing you want to do when you see a velocity with, like, an angle?
Hold on. Also, I want to ask, what is the -1 in the 75 meters?
Oh, yeah, so that's an exponent. So that s to the -1, all that means is that it's meters divided by seconds. Do you remember how, like, negative exponents mean, like, turn it into a fraction or, like, flip it?
Yes, I remember that.
Yeah, good. Yeah, so when they say ms to the -1, they're just meaning this is the same thing as m times 1 over s, and m times 1 over s is the same thing as m over s. Cool? All right. Okay, what do we do?
So I think from what I remember last time is that you gotta like use one of the things like sine, cosine, or tangent.
Good. Yeah, exactly. Yeah. I need to break up this velocity into components, okay? So I'm going to break it up into what we call like a Vy and a Vx, okay?
And so we know which sides are which, like where's the hypotenuse, the opposite, and the
Yeah, good.
adjacent.
Yeah. And here, we're going to save some time here, okay? Because notice how they're asking us what is the maximum height of the ball? Which velocity deals with how high something goes? Is it the x velocity or the y velocity?
It's the y.
Good. So don't even worry about calculating this right now. You know, we don't need to do it. Let's just look at what this one is. Okay. How do I calculate what Vy is?
Well, since it's like the opposite, I think you would use like sine to do it.
Okay. Yeah, good. Sine. Sine is equal to opposite over hypotenuse. We love that. Okay, cool. So what do I do?
So then you use what you have, like the sine of 22 degrees.
Okay. Sine of 22 degrees.
And then you have like, it's like Vy over 75 meters per second.
Good. So this is equal to Vy, good, over 75. All right. And what do we do next to solve for Vy?
You have to multiply 75 by both sides.
Good. Good. So that gets me that Vy is equal to 75 sine of 22 degrees. Okay. Which you need a calculator for this one. Calculator.
You always have to use a calculator.
So this is going to be 75 sine of 22 degrees. That's going to get us 28.1. Let's just estimate it. It's 28.1 meters per second. Okay?
Okay, sorry.
Good. Okay. So now that we have Vy, right? Now let's look at like what we're trying to get, right? What are we trying to solve for here?
We're trying to calculate the maximum height for a ball.
Good. We're trying to calculate maximum height. Very good. Okay. And so the maximum height is then going to be what?
Don't you think we have to find that?
Good. Yeah, but what variable is that?
All right. For the maximum height, you have to use Vy, right?
Mm-hmm. But then, so we have our equations, right? We have a couple of equations, right? We have, what is it? Y is equal to Y initial plus Vy initial t plus 1/2 at squared. We also have Vy is equal to Vy initial plus a times t. And then the other one you have is that Vy squared is equal to Vy initial squared plus 2a, and then we say this is delta y. Those are our three equations we use.
Okay.
Okay. Which one do you
So-
think we're going to want to use?
I think depending on the question, I think we use the second one.
Okay. The second one, yes. We could actually so it's funny, we can use all three in different ways depending on like what we're trying to do here. The
Even-
key here's a key little bit of here's a key bit of knowledge we need to know. When an object reaches its maximum height, okay? So let's say this ball is flying up in the air, right? And it reaches its maximum height. What do we know about what do we know about the velocity of the ball once it hits the maximum height?
Gravity starts to pull it down, right?
Pardon?
Gravity starts to pull it down, right?
Well, gravity's always pulling it down. But yes, you're right that it starts to move down, right? The velocity starts to become negative, okay? So the velocity here is positive, right? It hits its maximum height, and then the velocity starts being negative, right? Because it goes from moving up to moving down. So at the maximum height, what do we know about the velocity there? If it's going from positive to negative, what must it be at the top?
What must it be at the top? Don't get it.
Okay, sorry if you don't get it. Let's figure this out. All right, let's draw a graph. Okay, so let's say I don't think how to do this. Okay, so because I don't want to get too heavy with the graphs. Okay, objects on the ground, right? This has velocity being positive, right? Let's say the velocity at the beginning, I don't know, yeah, let's say it's equal to, what did we say it was? 28? Let's say it's equal to 28 meters per second, okay? And that's in the up direction, okay? And then now let's say the ball is slightly more up, okay? Let's say it's up here. What would you think the velocity is going up? Would it be more than 28 or less than 28?
Well, what I'm thinking of, when it's at its max height, I think it should be a little bit higher than 28.
You think the velocity is higher than 28? How is it gaining speed?
Because when it's at its max height, but it will be going higher.
Close. Let's think about that. Okay. Something at the ground, right, has a speed of 28, but then it has gravity always trying to push it down, right? Gravity always tries to push down. Gravity's like this mean bully that's like always trying to push things down, okay? So if I'm going at a certain speed here at the bottom, right? As I start going up, gravity is going to slow me down because it's trying to make my velocity go back towards the earth, okay? Does that make sense?
Okay.
So when the ball is going up, okay, the velocity is actually now going to be less, okay? In this case, it was a positive 28. Here it might be like a positive 10. Okay? It's going to start slowing down per se. Like it's not going as quickly up anymore. That make sense here, Ethan?
Yeah, I guess so.
Okay. Okay, and then it hits like some max height. Okay. Let's not worry about that yet because I want to illustrate something here. Okay. What's the velocity of this thing as it's falling down? What happens to the velocity in terms of like what the sign is?
Like when it's falling down, it will become negative now.
Good,
since
good.
gravity's not-
Good. So now this is v equals negative 10 meters per second. Okay. And then eventually the ball is going to hit the ground. Okay. And this is now it's going to be negative 28 meters per second. Okay. So do you see how, like, if I made like a graph, for instance, of velocity versus time, you see how the velocity started at like a positive 28, and then it was like a positive 10, and then it was a negative 10, and then it was a negative 28?
Okay,
Okay.
I saw that.
Yeah, you see how the velocity went from positive to negative? So,
Yeah, because when
keep going.
oh, sorry, so Yeah, like what you were saying. When something goes up, gravity is like trying to push your weight back down to the earth. That's what you're
Yes.
saying.
Yes.
So that's what demonstrates it. Okay.
Good.
That's what explains.
So somewhere in between the ball going up and the ball going down, it has to hit a maximum height, right? It has to hit like a peak. That's the highest it's going to get, right?
Yes.
Okay. If the velocity goes from positive to negative, what did it have to cross through? What number? Special number.
Oh, isn't it like 9.8?
No, that's acceleration. That's gravity. Let's look at Ethan. Positive, negative. What happens when I cross this line here? What's my velocity?
Isn't that in between a positive and a negative?
Yeah, what's in between a positive and a negative? What's a number in between
Isn't it-
-1 and +1?
Oh, 0.
Yes. 0. That's the key thing here, okay? What I want to show you here, Ethan, is that the maximum height something reaches is when its velocity in the y direction is equal to 0. That's the key thing here. Okay? Do you understand why? Do you see now why that is, right? Because velocity is positive, it's less positive, then it's 0, then it's less negative, more negative. Okay? This is the whole key thing. Good. Yeah, this is the big physics concept we need to know. Is that, like, max height is when Vy is equal to 0. Perfect. Okay, awesome. All right. So, I can now use, right, one of these equations to solve for how much delta y has traveled when I get to a maximum height where Vy is equal to 0. That's a little confusing. Okay. This is the point, right, where I'm at the maximum height. It's when my velocity in the y direction is equal to 0. Okay?
Yes.
Do you see how Vy is in a couple equations here, right? It's right here and right here. It's not this, because this is the initial Vy. I'm talking about like the final Vy is what it is.
Yeah, I see that.
Okay.
I see the difference.
Okay, good. Which one has the change in height in it as well?
Is it the third one?
Yes. This one. You see here? Nice.
Nice.
Yes. This is the equation we're going to use, okay? Because this will tell me how much y it has moved in order for the final velocity in the y direction to be 0. And when the final velocity in the y direction is 0, that's when it's at its maximum height. Okay?
Okay.
So all we have to do now is just plug in some numbers, okay? So for Vy, right, that's 0 squared is equal to the initial velocity in the y direction squared, which we figured out here, Ethan. Remember that?
Yeah.
Good. That's 28.1 squared. Okay, then it's plus 2. What is A? A is the acceleration, but what is that?
The acceleration of gravity.
Good. Which, remember, right? That's negative 9.8. Okay.
Isn't
then-
it negative 9.1?
Yes, 9.81 technically, yes. Well, it goes on forever. There's actually a ton of digits, but like some people will say negative 9.81, some people will say negative 9.8. Some people are like absolutely sacrilegious and they call it negative 10, which I don't agree with. Like, don't call it negative 10. Yeah, that's a terrible approximation. Negative 10? Like, what? Stop. But okay, cool. So the nice thing is we can solve now for delta y here, right? Because I just got to do 28.1 squared. I'm going to use this on the calculator, right? 28.1 squared. That gets me a number. So I have 0 is equal to 789.61. And then plus 2 times negative 9.8, so that's minus 19.62 delta y. Which, now this is easy. You know how to do all this, Ethan, right? I'm just going to move this over here. 19.62 delta y is equal to 789.61. Divide by 19.62. Right? Does that make sense, Ethan?
Yeah, and
Good.
then this gets us our final answer.
It does. So let's do it. Let's do this. Divided by 19.62. And yeah, we get our final answer, which is 40.245 meters.
That's dope. That's dope. That's dope.
All right, there you go. All right, right. Delta Y is equal to, what was that, 40.24. Yes. Good job, Ethan. Yes.
Can I ask you something?
Yes. What do you want to ask me?
Do you ever give your students assessments? Like, do you ever give any of us assessments to do? Like,
Uh,
before we review?
This is kind of an assessment. Oh, you mean like, I mean, I could give you another problem to do. I mean, what might happen is you may ask me tomorrow to do a similar question, and then I'll just have you do it. You know, that's a great way to reinforce it. In terms of like, do I go and just give you assessments? I honestly don't have the time to do that. I wish I did. But I have to help so many people that this is actually something I would like to have done automatically. For instance, for there to be like a course that you guys work through, and then that would give you assessments, and you can ask me for help on how to do whatever the pre-assessment questions, and then you can do an assessment question on your own, and then just to make sure you get it. If you don't get it, you can come back and ask for more help, right?
Yeah, but I feel like I'm still having trouble with kinematics.
It's okay. Yeah, we're gonna teach you physics this summer, so like we can just keep doing like questions like this, and it'll eventually start making more sense. And then if you really want, actually, I do have a course that I've built for physics students that I can maybe make available for you guys to go through to see if you know it. You know, it's one thing to learn it; it's another thing to practice it and actually do it. Yeah. Another quick thing here, Ethan. Physics is very cool because you can always solve things in multiple ways. Another way we could have done this, Ethan, is I could have used this equation, right? Because I know this is 0 to solve for t, okay?
Okay.
And then once I had t, I could have plugged it into this equation to figure out what the maximum height was. That's another way to do it. It's longer, though. You see how you have to use 2 equations to do it?
Yeah.
Yeah.
Yeah, I could see that.
Yeah. So, that's another way you can do it. Physics is cool like that. Yeah, what's up, Rampton?
Yeah, one thing I wanted to say is also like when it comes to questions like this, like for now, it makes sense that you remember 3 formulas, right?
Right.
But later on, all you have to remember is just one formula.
And just integrate it.
And so yeah, like once you know that, you can get all of these other ones just off of like knowing calculus.
Yeah.
Right. So these ones essentially just come from. It's actually like the better way of writing it. Like, is that the acceleration is the derivative of velocity with respect to time, and then you can get the rest of these. Like you can get this one from it, you can get this one, and then you can get this one as well. Like all 3 of these can essentially come from that one equation that you know. So once you when I like to tell people this because a lot of the times it's like, I mean, if you go into physics, then that's something interesting, but I do say like calculus as well, like comes in a lot of places in physics, and so
it does.
Like, and once you know calculus essentially, and you get good at math, you don't have to actually memorize a lot of stuff. Like the lesser you memorize, the better.
Yeah.
So like formula memorization is something that once you kind of get comfortable with the idea of like deriving equations, then you can forget about memorization, which is why I like math and not biology. Yeah,
biology is all just memorizing, like, which one's the Golgi apparatus? Which one is the endoplasmic reticulum? Always like so. But yeah, because a lot of times, Ethan, if you take like a physics course, they'll give you one of these huge, nasty equation sheets, which can be kind of overwhelming to look at. But in reality, a lot of these equations can be derived from like a single equation. So you don't have to know all of them. But Kind of helps. Why am I getting advertised? I don't want to go to Kohl's. What? Yeah, biology is like, what's the one like? Label parts of the cell. Like this thing, dude. I'm just like, what? Like, stop. Like, why? Why? I could just look this shit up. Why do I care what it looks like?
Yeah.
Or like this. There. Someone had a great meme about this. Yeah, dude, I love this one. I remember.
No,
this
that's like not even a joke. I literally had like a diagram like that on my exam in high school. I was like, "What is this?"
Yeah.
And yeah, our teacher had to be like, "Oh, because the ink was like black only." He actually had to like pull up the actual picture,
Yeah.
and then it was like, "All right, these are the things that you need to label."
Yeah. Yeah, dude, this one too. Label the parts of the cell. The cell just looks like this. Like, stop. Anyways. All right. Let's do Teacup's question. You're next, man.
Hello there.
You're still here. That's good. I'm pasting it in. Give me a second. Go wait for it to load. Wait, why is it not pasting? Come on. There we go. Ooh. Did you know there's a scaled copy of the Liberty Bell on the campus of the Harvard Business School? Here we compute its volume. Find the volume of rotation, symmetric solid. The radius is this, and the height is between 0 and 3. Okay. Volume of revolution. Let's see. I'm gonna change this because I don't like Z. I'm gonna call this X. You can change variables to whatever you want. Okay. Okay, so Teacup, do you remember how to do volume of revolutions, like for things? Remember the general equation for it? Teacup. We'll see if we can get Mr. Bean with the bell on his head. Are you there, Teacup? What's up?
Hello.
Yes, hello, I can hear you.
You have the integral sign with the A and the B.
Integral sign. Okay, yes, integral. Oh, sorry. Integral from the A to the B. Correct. Yeah. Then what else?
Pi.
Good.
Dy.
So it's pi r squared, and then in this case it's going to be dx, and I'll show you why. Okay. So this says 8 minus x minus. Oh man, that's a gross function. 8 minus.
It's also, I'm pretty sure this is supposed to be 0 to 4 in order for it to make sense.
Right?
Yeah, because like essentially what you can't think of is like, it's like a function that is like, it's like this, kind of.
Uh-huh.
And then at the bottom is where you're gonna have your maximum amount, right? So that's when, 0. Yeah. So one sec. So it
Wait,
has
no,
to
at
go,
0 your radius is the biggest, right? So they're doing it this way. They're saying this is
no, at 1 it has to be the biggest.
You're right. You are right, actually. Oh, that's weird.
Hey, Dr. Go.
What's up, dog?
Did you
This
forget to
picture is
select my
wrong.
phone?
Yeah, I did. I'm sorry. Let me give that to you. Good. Sorry.
Yeah,
What
this picture is wrong.
This picture's
So-
wrong, right?
Yeah, don't worry about it. I guess it's
They did the wrong thing.
yeah, like the picture doesn't look right because at the top in here, right, your radius is 0, right?
Good.
But if you plug in 3 into here, oh no, actually no, that's correct because you get 2 to the 3. That's fine. Yeah. So
Oh,
it's
okay.
between, but then one thing is that you go a 3 and then at 2 it becomes smaller because you would get
Oh, and at 0 it's negative, and negative cubed, negative cubed is positive.
Oh, it's cubed. Yeah. That's true.
Yeah, that cube is
Yeah,
screwing with us. Yeah, so this actually is okay.
Yeah, sorry, that's fine. Yeah.
Perfect.
Hey, also one other thing.
Yeah, what's up?
Did you check Friday's stream? I don't think you transaction my coins there either.
I'll check it. Or you mean the ones you bought during the stream?
No. I'm talking about like when I asked the question on Friday. I'm looking in the chat right now and I'm not seeing the transaction.
It's there.
No, for Friday's stream.
No,
on
I see
June
it.
14th.
Yeah, I see it on the 14th. It's there.
Oh, I think I asked the question first, right?
Yeah, do you see that? It's on the right here.
Oh, all right.
Yeah, you're good. Okay. Yes. Okay, this is okay. All right. 8 minus x minus 1 cubed, right? So what does this function look like again, dude? This is so gross. Oh, man. It's
You have to like square the.
It's like this. Is it like this? Is this what it looks like? I think this is what it looks
I
like.
guess, yeah.
Yeah, it's like a weird looking goldfish, or I know
No,
someone's
with
gonna.
the Z it already looks fine because you can assume that this is your Z axis,
Oh, okay.
like here, and then your X and Y plane is like this.
Okay.
And so the radius in here, which is R of Z, at
Uh-huh.
a certain Z, you have that R of Z, which makes
Yes.
sense because at 0, you get 9, and
Yeah.
then 1, you get 8, and then all that stuff.
Oh, yeah, you're good. Yeah. All right. Whatever. Yeah, teacup. We're gonna leave it. We're gonna leave it because I don't want to redraw this like weird looking shape. Because I'm gonna draw something inappropriate. I don't want to. Okay. Here we go. Okay. Z. This is R. Okay. And yes, this volume is equal to the integral from A to B, and then it's pi r squared. And then this d whatever, this is important. Whether this is dx, dy, or dz depends what axis has the symmetry. Okay? So, teacup, in this bell shape here, which axis is the axis of symmetry? What is this symmetric about?
The y-axis.
No, it's not the y-axis.
What?
Remember, this is the z-axis is what this is. Technically, this is a
y-axis.
because
Oh
it's
my
because it says because this is in 3D. This is a height z. They're calling this
decided
arm.
to change it back to y.
Okay.
We don't
can-
need x, y, and z. We need x, z, and y.
Okay. Fine. Let's call this x. You want to call this y. And then z, I guess, points out of the page technically.
I'm gonna confuse you now.
Yeah, you are. Okay. So this is really r of y is equal to 8 minus y minus 1 cubed. Okay? Because the radius, right, is dependent on how high in y you are. Okay? When y is equal to 0, you have a big radius, as Ramson and I showed. And then when y is equal to 3, right, this is from 0 to 3, you have 8 minus 3 minus 1 cubed. 3 minus 1 is just 2. 2 cubed is 8. 8 minus 8 is 0. And that makes sense here, because this is the tip of the bell. Okay? So good. So this is the integral from a to b, which is 0 to 3, because we're starting here, and we're going this way. 0 to 3. And then it's going to be pi r squared, which we're going to have to multiply this whole thing. This is gross. What? Squared.
I think that's supposed to be Z, by the way, not Y.
I know, he wants to make this y, is what he wants to do.
Oh, okay.
He wants to make this axis y.
I ruined his life.
Yeah, Noise, it's okay. You can laugh at this question. Yeah, I know. I know.
ruined his
This is
life.
why I didn't want to. I don't want to draw the bell. Not after I was googling how old is a 8th grader. Stop.
It's yo, that's gonna be a
I know. But yeah, this is going to be dy teacup because that's what this is symmetric about. It's symmetric about the y-axis. Okay. Cool.
Yeah.
Yeah. Okay. Now I need to evaluate this integral, and honestly, this is just ugly as anything. This is the ugliest integral ever, I feel like. So I'm not gonna do it, but I'll show you how you can do it on your calculator. Well,
you don't have to expand anything right away.
You don't. Yeah, I know. It's technically yeah. I know there's U sub and whatnot basically, but I'm just saying. Let me show you like some calculator skills here. If you want to integrate something here, teacup, all you have to do is type in the function, which in this case is going to be pi times, and then this is going to be 8 minus. But instead of y, we have to put x here because we're going to be graphing it this way. This is like x and like y. 8 minus, and then this is x minus 1 to the third. All of that squared. Okay. You see how I put this function in here? Teacup.
Hello?
Yes. Do you see how I put this function in here?
Yes.
Oh, it says this axis labeling is actually consistent with one of OpenGL. Oh, yeah. Okay. Is OpenGL still a thing? I feel like DirectX totally killed off OpenGL.
It still exists.
Does it?
What is OpenGL?
It's like
oh my god.
It's a 3D algorithm thing. It's like DirectX, like Direct3D.
DirectX but older and still good.
Yeah. DirectX is Windows, right? Yeah, OpenGL I guess is Linux, right? What is like oh, it's a graphics, yeah, it's an API. It's a graphics API is what it is. Yeah.
Okay.
What is Unreal based on then? Sorry. Like, do you guys know? Is Unreal DirectX or OpenGL? No, Unity is the other one. But okay. So, we can graph this. It's probably going to look really, really weird. Yeah, okay, cool. So we can let's zoom out a little bit. Okay. That's nice. Let me think.
Honestly, if you know Wolfram, Wolfram is a great.
There you go. There you go. This is kind of doing it, I guess. Right?
Yeah, you're seeing the side. Well, using Wolfram or anyone who has, I'm not gonna say, what's the expensive one? MATLAB, because
MATLAB, yeah.
But I mean, there's Maple, which you can do, but
Mathematica.
Yeah, Mathematica is another one. Yeah, Wolfram. I think Wolfram is the easiest one. You get.
The only issue is that they don't get Wolfram in the class. The reason why the reason why I show this specifically on a TI-83, TI-84 is because a lot of times in their classes, this is the only thing they're allowed to use.
Okay.
So if you want to integrate something, you type in the function, you go to second calc, you come here to integrate, and then you tell what limits. The limits, teacup, are these things that are attached to the integral sign. You see how you have a 0 and a 3 here?
Yeah.
So I'm going to put in 0 for my lower limit. I'm going to put 3 for my upper limit. And there you go. You get it integrates it for you. So this whole integral is then 473, I guess. Is that right? Do we know if that's right? Do you have the answers for this, teacup?
Could probably find it.
Oh, Vulkan. I don't know what Vulkan is. Pretty cool.
I don't know what Vulkan is.
There's a bunch of APIs out there. There's so many things. I know.
Yeah, I'll send you the entire answer.
You're gonna send me the whole answer? Okay.
Yeah, here you go.
Would you DM it to me or what?
I'm putting it in office hours.
All right, put it in office hours. Okay.
Here.
So.
I'll put the picture here if you want to.
Yeah, put it in.
Like this is more accurate as well.
They say pi 1053 over 7. Gross. Oh. 1053 divided by 7. Good. Times pi. Oh, look at that. 473. Same answer. Nice. And what? Oh, ooh, beautiful. Did you just graph this, Rampton?
No, Wolfram. That's what I'm saying.
Oh.
It's too good.
Oh, this is too good, dude. This looks great. Wait, but where's the bell shape? This isn't very bell shaped. Where's my?
No.
Where's my? Well, I thought it's supposed to be this way.
Let me see.
Is that right?
The function seems to be right.
Yeah, but it doesn't look like this.
Yeah.
Oh, you need to put a pi in there, and then, sorry, you need to square the whole thing. Rampton.
What was that?
You have to square the whole thing, put a pi on it, and then integrate it.
No, because that's the function that it's rotating, right? So it took
This
that
is
function.
this is R. This is R. Oh, I
Yeah.
see what you're saying. I see what you're saying.
Yeah, that's the R that is showing.
Oh, you know what it is? Because your X is going from 0 to 1,000. Try dropping this to like 3.
Yeah. For some reason, I'm saying it doesn't do 0 to 3. What?
I do like -1 to 3 or something. Anyways, good job there, Teacup. Starting to get a little bit. I wonder if my calculator does it. Noise says, how dare you say 1053 over 7 is a gross number? That's my favorite number.
It's my favorite number too.
Is
You guys
1053?
realize no one's favorite number is actually a negative. Like unironically, it is never a negative.
That is actually kind of funny, yeah. I don't think I have met anyone who has a negative number as their favorite number.
Mine is -17.
Is 1053 prime, though? Oh, it's not.
I don't
No.
know. Probably be simplified into like 45/7.
This is cool. You can actually ask Wolfram all the time, like, factors. 1053.
Does Wolfram do that?
Yeah. Oh, 3 to the 4th times 13. That's cool. That's dope. Yeah, you can ask it. You can ask Wolfram tons of things. It'll just do it for you. E to the I pi is my favorite number. Yeah, that's a good one. Yeah.
I love each of the iPie.
Yeah, we got
That is
13. We got 13 viewers. Oh, where'd all these viewers come from? What's up, guys?
Can I just say something? It is more likely to find someone with a favorite number of like 1,752,291 over like -1.
True. I forget. I don't think you can do 3D graphing in the TI-84. I think in the TI-89 you can, though. I think the TI-89 does have 3D graphing. I haven't found a good ROM for it to emulate it.
Wait. There we go.
You got the graph? Oh my god, it's a prime number of viewers. Yes, we love it. Yes, there we go. There's our bell.
Wait. Let's look that up.
Oh, okay, cool. There we go. It looks like a top hat, you know? We have like a nice little guy here or something. Like, yes.
Nice.
That's the nice end of the bell. Noise. Noise, stop, dude. Is that the noise end of the bell, Noise?
Yeah, the face on the bell.
I don't know. Okay, anyways. Thank you, everyone, for coming to Office Hours. Super fun. For all y'all that just found us on Twitch, we do this 3 times a week. If you ever want to figure out when
Well, 4 times, kind of.
We do, yeah.
Technically 4 times.
Technically 4 times, but we help you out with math and science homework 3 times a week. The 4th time is a fun, just lighthearted, we talk about whatever. But there's a schedule. You can always join our Discord there. to get more information on, you know, when we do events, ask any homework questions. You can earn prizes, tons of fun shit. But yeah, this was a very, very fun, productive office hours. Next stream will be, I feel like today's like Thursday or Friday, but no, it's Monday. Like,
Yeah.
I don't know, dude. The day's been going by so weird. But yeah, our next stream will be on Wednesday. That will be starting at 4 p.m. Pacific, 6 p.m. Central, 7 p.m. Eastern. So hop on by if you want to learn some math and science, or just ask whatever. We're here. I just CBA tomorrow. What's CBA tomorrow? Noise. What does CBA mean? Is this one of your British speak things that I don't know about? You said it was your last day of school though, too, right? I can't be arsed. I can't be arsed. Is that what CBA stands for? I can't be. But I would be like CBF. I can't be fucked. Like what? I like that. That's kind of cool. All right. Yes. So after we do office hours, which is going through homework questions and learning math and science, we then have actual gaming afterwards. So I play video games with you guys. If you want to come play Fortnite with us, we're going to do that on the actual gaming stream, which if you're chilling in the Twitch, don't worry, it'll automatically pull you over. If you're in the Discord, we have a recess voice channel that you can join and play us. Are you going to play Fortnite with us, Rampton? We're going to play Fortnite.
Fortnite? Probably not. I haven't downloaded it. I don't
go
know
get
if
it.
I can, because like, even with the new update on Warzone, I was like, what is going on?
No.
So, like,
The new update on Warzone is fucked. Like, people are getting half the frames they should be. And honestly, like, until the devs fix that game, I think I may not play it. It's so bad.
Okay.
I get
Yeah,
like half the frames that I'm supposed to. So I was thinking maybe we switch it to. Do you have Overwatch? Do you have Overwatch?
Yeah, I have Overwatch.
You were gonna say
I
League?
don't know if anyone plays League also. I could play League some days with anyone. if they
You know,
feel like
I've
it.
never played
Yeah.
League, but I would like to try playing League.
Oh, okay. Yeah, you need to make sure you're playing the casual thing, because like if your stream, like, it's bad how much, like, how toxic it is.
Oh, okay. Well, that's why I
Yeah.
do that on actual gaming. Like, I don't care what people say in actual gaming. It's fine. Like, that's my
Yeah.
my throwaway.
That's true. That's true. Yeah, that's actually a good point. Like,
Yeah, right.
separating
Like,
it.
I separate the education and the gaming because, you know, if people are gonna call me out in the gaming stuff, it's like it's fine.
Yeah.
But yeah, maybe we can try League on Wednesday, or Overwatch or Apex.
Yeah,
I
I
guess
think
those are all the games that
Overwatch-
people play.
I do have it, but I don't know if I need to update. I played it a lot in the beginning of the season. I do have it. Actually. Overwatch 2, right?
Mm-hmm.
Yeah, I played it a lot at the beginning of the season, and I was like trying to like get a rank, and then I got placed like bronze or something, like high bronze. But I was
Oh,
like,
so you were in like a high level or something?
No, I was like, okay, we're gonna be like, you know, it'll be fine. Like when we started playing ranked, because I feel like I had like 60%, a little maybe over 60% win rate when I was playing like normals, and then when the rank season started,
You get all the tryhards,
I
dude.
started playing ranked, and I was like,
It's like no good.
this is like a whole different ball game, and I was
Yeah.
just like 20% win rate. I was like,
Oh, no.
okay, I guess.
Oh no.